Number 1 has 4 parts to it, practicing how to solve logarithmic equations that are all set up in the same way. These are the notes that we are going over for logarithmic functions number 2. Again, if you don't have it, it's on my desk. So as you recall, this is where I taught you how to do the disco move. So we start on the bottom. Which number are we grabbing for part A?
4.
Go across the equation. You push up what number? 5/4. Go back to your heart, and what's the answer? X, right? Or I explained that another teacher on this campus told me this is how they do it. There's your bottom number. You dip under. You push this up, and you go backwards to write equals X. Either way works. As long as you write that down, then you grab your calculator. And we will use parentheses for the exponents. So 4 caret key, 5 divided by 4. We press enter. Nice answer of 32. By the way, this could be a problem, bless you. This could be a problem on your quiz where I would not allow you to use a calculator. And that's because based on your learning from last unit, I would expect that you know how to get this answer. Remember how we first applied the bottom part. So if I did that, remember this is 4 to the 1/4 raised to the 5th power. This represents the square root. What's the square root of 4?
2.
What's 2 to the 5th? 32, okay? While I get ready to go on to part B, just make sure your partner knows not only how to do it this way, but also how to do it without a calculator. 15 seconds, go. Okay, here we go. Here's your next one. So we start with 8. We bump up to negative 2/3 and equals X. Let's go for this one as if you are not allowed to use a calculator, and then we'll go back and we'll make sure our answer is right. So 8 to the 1/3 raised to the negative 2. So 8 to the 1/3. What times itself 3 times equals 8? And then 2 to the negative 2 means this isn't happy. We move it to the bottom. Now it's happy. 2 squared is 4. So 1/4 is our answer. But if you were allowed to use a calculator, how can we do this quickly? 8 raised to the, in parentheses, negative 2/3. And we get the same answer put back into a decimal of 1/4. 1 through 5, how well are you understanding these? 1 through 5. Okay. So with your partner, you have C and D to do at this time, C and D to do. I'm going to give you 1 minute. Whether you use a calculator or you complete without a calculator is totally up to you. If I do not specify that you need to show the algebra or complete these without using a graphing calculator, you are more than welcome to use a graphing calculator. But again, I do want to go back to make sure you understand the math behind it. 1 through 5 right now before we move on. It's okay to be 1 or 2? Most of us are 4 or 5. Okay, let's go on right now to number 2, please. Okay, so here we go. Listen closely. We have log of some number and log of the same number on the opposite side, and these two parts are separated by an equal sign. They each contain some quantity behind the log base 5. What's important is you don't see like a plus 5 that's back here. And you may say, well, if this one has a minus 2, what's the difference? This is contained in parentheses. The plus 5 is not. So when you have the same log and the base of the log is the same, we're going to cross out log base 5 and log base 5. We're going to solve for x, and then we have to plug it back in and remember the rules of logs. So I like to move everything to the same side that has the x squared. When the x comes over, it becomes a negative. And I'm going to do bottoms up. What multiplies to equal negative 2, and it combines to give you negative 1. And now if you are wondering, well, what are the rules of logs? This number right here that is following, this quantity that is following the log base sum number has to always, always, always be a positive number. Has to always be a positive number. So let's try 2. 2 squared is 4. 4 minus 2 is 2. Okay, that's good. So on the left side, I have log base 5 of 2. And then I substitute 2 in for the right. I have log base 5 of 2. This works. Let's try the negative 1. Negative 1 squared is 1. 1 minus 2. 1 minus 2 is negative 1. And on the right side, I substitute in and I also get a negative 1. Most students are going to make the mistake and say, hey, that works. It's the same on the left as it is on the right. But the problem is, remember, you can never have a quantity behind a log base of a number that is negative. That means this is an extraneous solution. I only want you to go into B. You have 1 minute to complete it and check your answers with your partner. Begin. Okay, so same log base, we have quantity and quantity, no extra numbers that are not in parentheses. So I get to do x squared minus 15 equals 2x. I move the 2x over to the opposite side. And now I get to do the bottoms up method. What multiplies to equal negative 15 and combines to give you negative 2. X equals 5, x equals negative 3. I can tell right away that when I plug in a negative 3, I'm going to get a negative 6. It won't work. Let's try 5. 5 squared is 25. 25 minus 15 is 10. And 5 times 2 is 10 as well. This works. 1 through 5 right now. 1 through 5 on your understanding? Okay. You are not going to do C because C is different. We're going to do that together. You're going to do D on your own, but I just want to go over something first. The most common mistake made in previous years on this type of problem is students forget the bottoms up part. Okay, on your own, a minute and a half, go. check with your partner when you're done. Ooh, is this factorable?
Yeah.
Let's try -2 and -3. Does that work? Or -2 and -1, excuse me? So this multiplies to give you a +2, combines to give you a -3. Don't forget about the bottoms up. Before I check anything, can you raise your hands if you were able to receive an answer of 1/2 and 1? Hands up high. Okay, so I'm going to check here. Let's see. I'm going to use a calculator to do this. 3 times 1 obviously is 3, minus 1 is 2. Okay, I want 2 here. When I plug in here, 1 squared is 1, 1 times 2 is 2. This works. Let's try 1/2. 3 times 0.5, subtract 1. So I have a 1/2 in this section. Over here, if I take 0.5 and I square it times 2, I get 1/2 again. How many were able to get them both to work? Hands raised. Great job. Come back to the left-hand side. There is no difference between A, B, and D, and C, but some people may be a little more intimidated by C because of the amount of terms. Same log, same base. I'm going to choose right away to save some time. I'm going to move everything to the side that has the larger coefficient on the x squared. When this moves over, it becomes -x squared. A -x squared and a +3x squared is a 2x squared. When 4x joins a 7x, it becomes negative as it comes across the equal sign. 7x and -4x is +3x. Same thing, as 2 comes across, it becomes negative. Joining the -7 is a -9. With your partner, please solve. Don't forget to do bottoms up. What multiplies equal -18 and combines to give you a +3 would be 6 and 3. Just checking. Remember to do bottoms up. This is 3, but opposite of +3 is a -3. I'll just go like this, you can see. And the opposite would be a +1/2, or 1.5. I'm going to go back and check now. -3 squared is 9. Once again, -3 squared is 9. 4 times -3. 4 times -3 is -12 plus 2. Because when I substitute -3 in for x, this quantity equals a negative. I know you cannot have a negative quantity in this position, so this is an extraneous solution. I'm going to check 1.5 next. 1.5 squared plus 4 times 1.5 plus 2. 10.25 on the left. Let's see if I get 10.25 on the right. Okay, when I did this answer, I have x equals -3 does not work. It becomes an extraneous solution. 1.5 does work. Does anybody have questions on these? Would anybody like me to show my work and how I was able to check them? Okay, we're going to flip to the back side. Application type problems. Have one person between the two of you, unless you're by yourself, read it to yourself. Please just read the first statement before we do part A. Begin. So in part A, they've already told us that the L, which is the loudness of this, the loudness of a fireworks display is 130 decibels. So in this position is 130. We want to solve for R. So let's go 130 equals 10 log base 10 of R. By the way, what type of log is this? We learned that term yesterday. Remember, that's the only type of logarithm that your calculator can actually solve. Let's divide both by 10. And let's think simple. Before you actually pull out a calculator, when you have a 0 on top and the 0 on the bottom and their end, you cancel them out. 13 divided by 1 is actually just 13. Now, sometimes students, when they initially start to solve logarithms, get a little confused when it's like this, versus when you have the log on the left and the answer on the right. Either way, doesn't matter. Okay, you can think of this as the disco move. Putting your right finger on your left hip, raising up to grab the 13 and setting it back to the answer. So again, this is our base. We raise up the 13 and set it equal, going backwards to the R. Now we are not going to plug that into your calculator. That's in scientific notation. Turn to your partner, because this is very important. You start learning this in 7th grade, and even by junior year, students still get confused with this. What does this represent? Like if you were to tell your partner this is what the number would look like. 10 seconds, what would it look like? Ready to go. Just explain it. Okay? All right. Let's circle this. I would like you to do B with your partner, and you have 45 seconds to begin. When you're done, look up at my answer, which is located on the board. So I reduced it down here, but these are ultimately the same thing. Would anybody like me to go over how to get the answer to part B? All right, so down here, how many times more intense is the fireworks display than the concert? In other words, find the ratios of their intensities. When you think ratio, what mathematical process do you think of? Yes, a little bit louder for me, please. Division. So if I said the ratio of boys to girls in here, and I'm just going to take a guess. Felix, please make sure your phone doesn't come on, okay? If I said the ratio of boys to girls, it may be something in here like 14 to 7 or something like that, okay? Boys to girls, boys goes on top, girls goes on the bottom. So we want the ratio of fireworks to concert. So what was the fireworks answer? 10 to the 13. And the answer for the concert, which is second, is 10 to the... What is half of 15? 7.5. You have the same base and you're dividing. Turn to your partner. What operation do you do with the exponents? What is 13 minus 7.5? 5.5. There's our answer, 10 to the 5.5.